Okay, so now let's talk about a very important concept, which is representation of a vector. Okay, now last segment we saw the equality and equivalence of vector, and then when we talk now about how to represent a vector, so then the equality will be very important to convince yourself that okay, these two vectors are equal will help you in representing a vector mathematically from one form to the other. Now, what do I mean by that? Okay, see, in a book or in any context, if you want to convey to somebody that there is a vector of this much magnitude or this much or in this direction, how do you represent? Primarily by picture, right? So suppose in a book you see something is given like that, say this is x, this is y, and this is z, and we will always follow this right handed axis, right. So if you turn x towards y, so through the right hand thumb rule, so when you move x towards y, curl like that, so the right handed screw should move in the thumb direction, okay. So the z direction, so that's our axis direction. Now in that, suppose somebody has represented a vector like this in the drawing as a picture, okay, and maybe the coordinate of the tail is somewhere here, maybe I wanted a dotted line, okay, maybe this is that and this and like this. So that means the tail is at say A1, B1 and C1, okay, and the tip is similarly at A2, B2 and C2, okay. Now if you want to represent this vector mathematically, because to visualize somebody has drawn it, it's fine, but then if you want to calculate something with it, you can't just do that from the drawing, right. So for that you will require it to be in a mathematical form. Now to do that, what would you do? You have to think that this vector is exactly equal to the vector if I draw it here, because there is no difference. Now we are using the concept of equality. This vector is exactly same as this, you have just drawn it somewhere else. Why you are doing that? Because now it will be easier to think about how to represent it. Now you have shifted this, so this point has come to the point 0, 0, 0, and this point would have come to A2 minus A1, B2 minus B1 and C2 minus C1, because everything you have shifted, okay. Now this point here, okay, so will become say A2 minus A1, B2 minus B1 and C2 minus C1, okay. So that will be the point. And now you suppose you imagine that the unit vector in this direction is I, which we will always represent the unit vectors in x direction as I unless otherwise specified, and in the y direction suppose this is j and the z direction, suppose this is k. Okay. Then this vector's mathematical represent, let me give it a name. Suppose the vector was a. Okay. Now this is one representation of the vector. This is called the symbolic representation. Okay. Simply, before that I had drawn this, so let me call this a pictorial representation. Okay. And this is a symbolic representation. So now you know two representation of a vector. One is one arrow like that, either you show somebody like this, some arrow, or you draw something like that, which we will call a pictorial representation of the vector. Then you just attach a symbol to that, and that will be called a symbolic representation of the vector. Okay. And now if you write this in terms of, see, now the vector has come here, and it is easier now to just write it like a2 minus a1 in I direction plus b2 minus b1 in j direction and c2 minus c1 in k direction. Okay. So this is called the component representation. So let me now do one thing. I'll put a here, I'll put a list maybe, or on this side. Okay. Let me put here. So the first one we saw, is it coming in the picture? Yeah, it's coming in the picture. So this one we say a visual or pictorial representation, the arrow. Okay. Then second, symbolic representation of the vector, and third one, like this, if you represent, we call this say component representation. Okay. So this is the component form, a component representation of a vector. Now for you should think about a very important point, which is to draw an arrow or to show somebody something like a physical object like this, which can represent a vector, or even to put a symbol. You do not actually require to define a coordinate system. You do not require that, right? You can just imagine this arrow without all these coordinate system. Still a vector can be shown, and you can talk about that vector just by the symbol or the vector arrow. But as soon as you come to represent it in the form of components, you would require a coordinate axis. Okay. Now initially it may look like, why is it so important? We will slowly see that this is one of the very important concepts of using vector. Okay. We will discuss a lot about that. Now yeah, so for these two you do not require to actually formally define a coordinate system, but for this you have to have. But then as soon as you define a coordinate system, that you could have done by introducing any sort of coordinate system. Why only Cartesian? You could have put a cylindrical coordinate system, you could have put a spherical coordinate system, and then there are many types of coordinate systems. You could have put any of them, and in those coordinate systems, in terms of those coordinates or their unit vectors, so these unit vectors would have changed, and in that coordinate system the respective components would have come. Okay. So that would have been a representation of this vector in that coordinate system. For example, let me write it in some other coordinate system. For example, say, and then as soon as I change the coordinate system, most probably and most generally these components also would change. So I would say they will be maybe say x, I'll put say xyz. So x, this is bad. So x2 minus x1, say my unit vector in another coordinate system is say ER plus y2 minus y1 times E theta. In fact, we will be talking a lot of things about these kind of coordinate system in due course. Now I am just giving some example. I mean, don't even bother yourself about what ER, E theta and EZ are. Just some different coordinate system in which we are representing them. And Z2 minus Z1 EZ hat. Now the same vector now has been represented in a completely different coordinate system, which will have different components, different unit vectors, and but note that the vector is the same. So that's a very important concept. That means the arrow which you had drawn or the symbol which you had given and the physical quantity that this arrow was representing, that has never changed. Just by introducing the coordinate system, the components have changed. Okay. As soon as you change these unit vectors through which you are representing, the components have changed. So that's, we call that a vector is a vector is a vector, whatever coordinate system you use. If you are talking about a velocity, the velocity of the particle is not changing by changing the coordinate system, because that is your artificial way of representing this physical quantity. Okay. So please note this very carefully, because this is a very important concept. We will talk a lot about this. Yeah. Now this is one way to represent, and another way is say fourth point is unit vector representation. Okay. Now what do I mean by that? What you can do is the same vector, you can represent that maybe I'll put say this as, you can take the unit vector of A, the magnitude of A times a unit vector in that direction. Okay. So please note that this is a very, very powerful representation of any vector, and you will be using this infinite times in the process of solving numerical examples. Okay. Now this was component form, this is a unit vector form. Okay. Now so what does it mean? So that means, see, you have to represent, get the magnitude of this, the length. You know how to do that. That means this square plus this square plus this square under root. So that will give you the magnitude of the vector. And this is, you know, is like I'll put, okay, a unit vector in this direction. Okay, a vector whose length is 1 unit. Okay, but direction coincides with the actual vector. Okay. In fact, I should have drawn that to be more specific here. Okay, because this is what A is, but again from equality of vectors, this A and this A are exactly the same. There is no difference between that A and this A. Okay. So that means this vector A multiplied by the length is the vector capital A bar. So, we will in general, means always in this course, we will represent the unit vector in a particular direction with the small letter with a hat on that and the magnitude like this, and the whole vector as a capital letter with a bar on it. Is that fine? Okay. Then there are some other representation which are not very important for us in this course, but I will just write them down. One is let me put it here, say fifth one as a complex number. Okay. Now, but this is very specific to 2D systems. If you are doing everything in a 2D plane, then it is very convenient to represent the vector in a complex with complex numbers and then do all the algebra in the complex plane. You might have done that in your 12th standard. That is one of the very convenient way to represent vectors in 2D. Then there are some other like and there I will say element, this I do not like, element of a vector space. Okay. So, just for completeness I am writing it, you need not worry about that much. As we go into other subjects like maths, where we will discuss about vector spaces, then you will see that how a vector can be thought of as an element of a vector space. So, that will be very interesting. In fact, that definition of a vector or representation of a vector will be the most power of all of these things. In fact, this and this are the most powerful representations of any vector. You can do a lot of things with them in a general sense, then to do specific calculation under a specific condition, you can then introduce a coordinate system and do all the algebra of manipulation. Okay. So that is how roughly there are some more representation, but to us they mean they do not mean anything. In fact, we will be using mostly these four. Okay, I will put a sorry, yeah, these four representation of vector in this course, but these two will be you will see, in fact all the four. So, you should be very comfortable, and we will discuss with examples how to go from one form of representation to the other and the other from other, and in which circumstances which representation is useful, what is the advantage of one representation of the other. So, all those things we will discuss. This was just to introduce yourself to the various forms of representation of a vector. So, see you in the next segment.